Hello classmates. In today's lesson, we will discuss trade temperature gradient and side stream temperatures. In daily life, family cars generally need to go to gas stations to refuel with gasoline, while some trucks need diesel. Both gasoline and diesel originate from crude oil. Distillation is the method used to separate gasoline and diesel from crude oil. So, can we use a single piece of equipment to distill two or more components? Unlike simple two-component distillation columns, the atmospheric distillation tower in the petroleum refining industry can produce multiple products. These products are drawn from side streams, referred to as the first side stream, second side stream, and so on. As shown in the diagram, these are the side stream temperature parameters for a specific company's atmospheric tower. First side stream outlet temperature 183 degrees Celsius. Second side stream outlet temperature 253 degrees Celsius. Third side stream outlet temperature 309 degrees Celsius. This raises a question. Is there a temperature difference between the top and bottom inside the atmospheric tower? Consider the food steamer in the right-hand diagram. Each layer has the same temperature, 100 degrees Celsius. If the temperature were uniform throughout the atmospheric tower, the vapor composition would be the same everywhere. Then, no matter from which tray the product was drawn, the product would be identical. Through top reflux, intermediate reflux, etc., light components rise through the trays as vapor, while heavy components descend through the trays in liquid form. This causes the temperature to gradually increase from the top of the tower to the bottom, forming a temperature gradient inside the tower. As shown in the example case, tower top 126 degrees Celsius, atmospheric tower bottom temperature 359 degrees Celsius, the temperature increases stepwise from top to bottom. Only when this temperature gradient is established can the material composition on different trays distribute in a graded manner. This enables the atmospheric tower to draw different products from its side streams. There are three main principles for temperature control in the atmospheric tower. Top temperature, controlled using top reflux and its temperature. First side stream temperature, controlled using the top temperature, or the side stream draw rate, and the first intermediate reflux. Second and third side stream temperatures, controlled using the side stream draw rates and the first and second intermediate circulating refluxes. The goal of the process is to obtain products. Variations in product quality are inevitable in production. Below are several primary adjustment methods for product quality issues. First, too light. Manifestation, low initial boiling point, for lubricant fractions, low flash point and low viscosity. Cause, indicates lighter components from the preceding fraction were not fully vaporized/distilled. Treatment, increase the draw rate of the preceding side stream product. This reduces the internal reflux flowing down the tower, raising temperatures. Alternatively, increase the stripping steam for the current side stream. Both help drive off the light components, resolving the low initial boiling point or low flash point issue. Second, head heavy. Manifestation, high initial boiling point. Cause, often due to excessive draw rate from the preceding side stream. Treatment, appropriately reduce the draw rate from the preceding side stream. Third, end light. Manifestation, low dry, or end point, reducing the yield of the current fraction. Treatment, increase the draw rate of the current side stream, or open the side stream stripper bottom valve, to ensure the complete withdrawal of the intended fraction. Tail heavy, end heavy. Manifestation, high dry point, high pour point. For lubricants, high carbon residue. Cause, indicates heavy components from the next lower fraction are being carried over. Treatment, decrease the draw rate of the current side stream. This increases the internal reflux returning to the lower section, lowering temperatures. Alternatively, reduce the vaporization or stripping of the next lower side stream. Both reduce the likelihood of heavy component carryover, bringing indicators like dry point, pour point, and carbon residue back within specification. By maintaining a reasonable temperature gradient distribution and adjusting according to different production schemes, various qualified side stream products can be obtained. Taking a 1.2 million tons per year atmospheric residue unit product slate as an example, atmospheric overhead used as catalytic reforming feedstock. First side stream, Atmos 1 used as jet fuel hydrotreating feedstock. Second side stream, Atmos 2 used as transformer oil feedstock. Third side stream, Atmos 3 used as gas turbine fuel. First vacuum side stream, DAC1 can be used as fuel oil. Vacuum side streams 2, 3, 4, DAC2 to 4 serve as feedstock for different grades of lubricating oil. Fifth vacuum side stream, DAC5 can be used as asphalt blending oil. Vacuum residue, used as road asphalt. Classmates, only by pursuing perfection can one become a master craftsman. Adjusting distillation tower parameters should aim for edge point control. Edge point control involves manipulating process variables to ensure product quality is just within specification limits. This achieves the goal of maximizing product yield, minimizing unit energy consumption, and thus maximizing the unit's economic benefits. This is crucial for side stream product quality control. When producing kerosene or jet fuel from the first and second side streams, strive for edge point control regarding flash point to avoid excessive quality overshoot, saving stripping steam and reducing the overhead condenser load. Depending on the scheme, if the third side stream produces heavy diesel, consider minimal stripping steam with edge point control focused on flash point. If it produces light diesel, consider operating without stripping steam, focusing control on the dry point, which also reduces the overhead vapor load. So-called edge point operation means achieving the highest possible diesel yield while ensuring product quality meets specifications. This requires patient and meticulous adjustment by the operator. The craftsman spirit advocates dedication, focus, continuous improvement, attention to detail, and the pursuit of excellence. In your future work, you must constantly carry forward this craftsman spirit. As the saying goes, achieving perfection in small things is the greatest success. Alright, that concludes today's lesson. Goodbye. See you in the next class.